Okay, this is problem 4 from 2017. We are supposed to, for part A, write an equation for the line tangent to the graph of h at t equals 0. So right here, they give us the point, which is 0, 19, and we want to use the tangent equation to approximate the value of the temperature when time is 3. So we have the point, we've got to come up here, and here's the slope, which is the derivative. So we want to plug our h in, and this is t, and this is the h value over here, the 91. So we're going to get negative 1/4 times 91 minus 27, and that's 64. Negative 1/4 of 64 is negative 16. So my tangent line is y minus 91 equals negative 16 times t minus 0. Now you didn't have to put the minus 0 there, but you could. And now we want to take this 3 and plug it into right here. So we get y minus 91 is going to equal negative 16 times 3, which is y minus 91 is going to equal negative 48. And then we're going to add 91 to both sides. And we're going to get, and we probably should have been using h here instead of y, but it doesn't matter, it'd be okay either way. So we would get that the temperature was approximately 43 degrees. And we should, well, we don't have to, but it is Celsius. But it doesn't say to give the units, so don't give the units because you could mess it up if you put the wrong units. So we would want to be at the time t equals 3, the tangent line approximates temperature to be 43 degrees. Okay, part 2 says find the second derivative of this function. And then we want to tell whether or not part A is an underestimate. So I'm going to write 43 degrees up here. I guess I probably don't need that really, but we want to know if that was an underestimate or an overestimate at time t equals 3. So we need to do the derivative of this thing up here. So we're going to do the second derivative of h with respect to time t, which is going to be, leave the coefficient the same. The derivative of h is 1, but it is with respect to t, so we must do a implicit differentiation and put the dh dt on there. So that would be that part. And then we're going to want to plug in this thing up here that was given as dh dt back in for that. So that's going to be negative 1/4 times negative 1/4 times h minus 27, which is going to end up being positive 1/16 times h minus 27. Now, up here in the problem, I didn't talk about it. It says the internal temperature is greater than 27 for all times. So that means that since this h right here has to be greater than 27 for all times, that means that the second derivative of h dt is greater than 0. It's a positive, which also tells us that the function is concave up. So h is concave up. So what that tells us is that our original 43 degrees is going to be an underestimate of the temperature. And here's why. You do not need to make a graph, but I'm just trying to show you what it's teaching us here. When we got this object cooling, it is coming down and it's kind of curving here. It's not as jiggly as I have it. And right up here, it's 91 degrees. And then we found a tangent line going through that 91. It looks something like this. So our t equals 3. T equals 3 is in here somewhere where you got a point right here. that was 43 degrees. That's what we found for number 1. But the actual point is up here above it. So our estimate for part A would be an underestimate. So we would say an underestimate A is an underestimate because the second derivative of H is greater than 0, concave up. So that is problem number 2. Problem number 3, part C, I should say, says for t less than 10, an alternate model for internal temperature of the potato at T minutes gives us this differential equation right here, where G of T is measured in Celsius. They're giving us the same point, 0.91. So at times 0, it's 91 degrees. Find the expression for GT based on this model. So in other words, we're supposed to solve for G. So we have to separate variables. So on the DG side, we need to divide this G minus 27 to the 2/3 power. And left over here is our negative sign. We need to multiply the dt over to that side. Then we're going to integrate each side. So we are going to have to do what I told you you're going to have to do on this AP test. We're going to have to let U equal G minus 27. So du is going to equal dg. So this is going to give us the integral of 1 over u to the 2/3 du. And then we're going to go ahead and take the integral of 1, which is t plus some c. Now on the test, I told you this, we did one before, but that denominator is not natural log unless the exponent is 1, and that's not 1. So the first thing we must do is we must bring that up to the top to make the exponent negative. And we're done over here on the right side. And now we can add 1 to that. So that's going to be u to the 1/3 over 1/3, which means you flip it upside down and get 3 in front. And then we've got to plug in the G minus 27 again. So I'm going to erase some of this so I can do this problem over here. So I'm going to have 3 times G minus 27 to the 1/3 power is going to equal negative t plus some c. Oops, do that again. 3 times G minus 27 to the 1/3 power is going to equal negative t plus some c. Now I'm going to plug in my point, 0.91. So I'm going to get 3 is going to equal 91 minus 27 to the 1/3 power. And that's going to equal 0 plus c. And then c is going to equal. So 91 minus 27 is 64. And the cube root of 64 is 4. So c equals 12. So our equation is going to be 3 times G minus 27 to the 1/3 power is going to equal negative t plus 12. Now we are supposed to solve this for G of t, so we got to keep doing the math to solve this. So we're going to divide each side by 3. And then we have to cube each side, and I've run out of room again, so I'm going to cube each side. And then I got to add 27 over. So my equation is g of t is going to equal negative t plus 12 over 3 cubed plus 27. And that's another point for solving for g. And then the last thing we got to do is it says find the temperature of the potato at time 3. So now I got to plug 3 in. So you can quit right there. That's the temperature. But I should have put a 3 in over here too. I should put a 3 right here. Now that is the temperature, but when you get done, if you go ahead and solve it, you can quit right there. There's 54 degrees Celsius. So as you can see, back on A, if you remember, we had 43 degrees Celsius, and do you remember we said that was an underestimate? Do you see how that's less than 54? So that's kind of a check for that.